Welcome back for the online class. Let us continue about the topic morphological image processing. In previously we were discussed on the basic algorithms, erosion, dilation, opening and closing. And I previously discussed about the basic algorithms on erosion and dilation. Okay, just in brief, the erosion will be for erasing the image, that is for thinning purpose, and dilation to get added the data content for the purpose of image thickening application. Now let us consider the next algorithm, that is hit and miss. Now it is a hit and miss is useful for to identify specified configuration of pixels. To identify the set of pixels in an image, it is most used algorithm. For instance, such combinations as isolated foreground pixels or pixels at end of lines. This is the basic operations we will be used for hit and miss operations. Now, the symbol for the miss, hit and miss will be given here, circle and cross. Okay, this will be considered as a symbol for hit and miss. Okay, now A is an image, B is your structuring element. Okay, I hope I discussed on the structuring element previously also. Some more structuring element we will see in the class, coming up class. Okay, A is hit and miss. Okay, hit and miss with B. B is structuring element. Now when we are performing, okay, now equation of hit and miss will be given here. A eroded with a B1. B1 is nothing but a one structuring element. B1 is a structuring element. A is an image. A erosion B1. Okay. Now after performing, you end up with a certain kind of output. Now second operation, A complement means complement of the image, what you are interested. Take a complement of this. When you are complementing nothing but all the 1 will be converted to 0, zeros into 1. It's a complementary operations on an image. Okay, there are like a few built-in for programs which are available like MATLAB, Python kind of things. The complement operations we can easily perform. Okay, it will be come up with like a complement. And after this A complemented operations, you perform, there is erosion on B2 element. B2 is again the structuring element. There are like a two structuring element will be considered for the purpose of hit and miss. One is B1, one is B2. Okay, that is A erosion B1 and say vice versa. Okay, A complemented data, complemented image with eroded with a B2. Okay, now you end up with the two information from this one, second equation. Now on which whatever the obtained data, you find intersection. The intersected data, this is a common data which is available from the both the operations. You need to be you need to be performed. Okay, and whatever the final output you are getting it. Okay, it is the algorithm on hit and miss operation. Okay, now we will see what are the importance, what are the applications you are using it, this hit and miss. It seems to be very simple for the operations. Okay, now let us consider with the example so that I will make the clear content on this equation. Okay, before we start with the example, there are like a few structuring elements can be considered. Okay, now this is basically we are using it for the boundary operations. As I told, the hit and miss is for a boundary operations where you are interested. The interested region of the image is boundary, for which we are using hit and miss. Okay. Now there are here I given with 5 basic elements. There is a structuring elements. Among that, you can use any one for the purpose of operations. First one, second, 3, 4 and 5. Hope you can see. Okay, now there is a configuration of 1 and 0. Okay, now 0 will be available here, 0 exactly at the corner. Now in the structure, second structuring element, 0 is available here. Okay, means here, here, here. Okay, now what the purpose of this one? If I consider, okay, this is something like if there is an image will be there, and if you are interested in this region, okay, you are using one of the structuring element, like you can use 5th structuring element. And if you are interested in this, okay, boundary of this one, okay, we are using a 4th one. Now similarly, if you are interested in this one, okay, the boundary of an image, you are using with the 3rd one. If you are interested with this region, we are using a 3rd structuring element. And if you are interested in between of this image, we are using a 1st structuring element for the purpose of image boundary detection. Okay, anyway, we'll come to know how we will use it, this one. Okay, now let us consider with an example about the how hit and miss. Consider, okay, there is an image is given here, A image. This is a A image. Okay, now hope it is clear here. Okay, now what you are performing? You are performing A erosion B1. B1 is nothing but your structuring element is given here. Okay, the B1, the center pixel will be 1. All there is a vertical and horizontal value contents will be 1, 1. Okay, now what you perform? You just take the structuring element, keep it on pixel by pixel. Okay, now when you are keeping it on this pixel, okay, there is a very much first pixel. Okay, look at this. Okay, now when you keep it at the very much beginning pixel, okay, sorry, you just keep it on the leftmost corner pixel. Okay, now when you keep the pixel over here on the pixel, you keep the structuring element B1. Okay, when you're holding it, okay, you just check it that this portion, okay, very much light portion, leftmost portion of this one. Okay, now is exactly matching with the B1? No, means you have to make it here as a 0. Okay, now similarly, you just B1 is a structuring element. B1 is a structuring element. You keep it, go on, keep this one on all the pixel. Okay, now let us consider that if you keep it at this position, okay, now there is an exact match of a B1, so only the middle pixel will be retained. Okay, this pixel will be retained. Okay, that is a 1 will be retained. Okay, the outer will be erased. Okay, now how the operations we are performing here, look at this one. Okay, now if I keep it on this one, okay, like this center pixel, if this is a center pixel, okay, now consider this is a center pixel. Now there is no exact match of the B1, so this pixel will be get erased. I mean to say there is like only one configuration. There is like only one configuration in which you can find a common. Okay, that is means the B1 when it is getting mapped on pixel by pixel from each one pixel. Okay, there's only one single match is available, that is this one. This one, okay, means only one value will be retained. Similarly, when you are keeping, okay, like look at this one. If I keep it here, pen, okay. When you keep it here, the pixel, okay, look at this, okay, this is a center pixel, okay, the structuring element is B1, so which is not matching, means this will be get erased. Okay, similarly, when you move it one right side, this is also not matching with the structuring element, this is also get erased. Similarly, this is also get erased, this one is also erased, means all this pixel will be get erased. When I take this one, okay, when I consider, sorry for this one, okay, I'm getting some technical issues with the content, okay. Now there is like only one value will be matching, this pixel, means out of these operations A erosion B1, only the corresponding 3 pixel will be retained, that is 1 pixel, second pixel and the third pixel. That is what you have performed here, A erosion B1, A eroded by B1, okay, because wherever the pixel of B1 is exactly matched on A, you retain that pixel, center pixel, the rest all will be get erased. Hope you understood this, okay. Now similarly, when you are performing, okay, when you take the B2, okay, look at this one, okay, that is what I am performing here, okay. Now I have to perform A complementary, okay, that is erosion on structuring element P2. Now B2 is given here, okay. Now you go and keep it same way on each pixel. Okay, on each pixel you keep it there on a B1, okay. Now when you are performing, you need to be perform A complementary in the sense the content, I hope the A is visible, okay, that is the image A, take its complementary, all 1 will be turned to 0, 0 is to 1, okay. Now the image will be, set of image is available for you, set of image is in front of you, okay. Now wherever it is getting matched with the B2, okay, it will be get retained, the other part will be get erased. When you're performing this type of operations, you will end up here, the structure like this, okay. Now how it will be getting performed here, okay. Now I'll just I'll say simple here, 1, okay, in all the boundary I'll take here 1 1, okay. When you keep this structuring element here, this area, okay, now there is like a empty space is indicated with a don't care, okay. Now the 3 of the 4, 1 2 3 4, only 3 are matching, this 0 is not matching, means the center pixel value will be turned to 0. Hope you understood this one, okay. Similarly, I'll just take a randomly, I'll find out about this one, okay. Now I'll keep my structuring element here, what are the data I get here. Now when you consider, okay, you just consider, okay, this one, center pixel value, okay. how I actually got here. Okay, now you keep the structuring element here. Okay, all the way on this place. Okay, now is it exactly match here? This one is there. Okay, this is a don't care. This one is there, exact match. This one is there, exact match. This one is there, yes. This one is there, yes. This is a don't care. This is the don't care. Means I have retained it. It means that one of the structuring element, if there is the 4 pixels are exactly matching, then you retain that value, or else you erase it. Now if you perform on an image, if you are sliding the structuring element full on an image, you will end up with a image like this. That is a complementary erosion on B2. Okay, that is when you observe, okay, like A eroded B1 and A complementary eroded B2. Okay, you need to look into the pixel which are common among both the images. If they are common, then you retain that value, or else you make it with a 0. Okay, now how it will be made? Okay, now look at this one. A eroded B1. There are like only 3 values. Okay, you just observe the position 1, 1, 1. Okay, now this is one of the output you got here from A complementary eroded with the B2. Okay, only 3 pixels are common that need to be maintained. Okay, now when I am maintaining this one, okay, that is at this position, the 3 pixels, 1, you just look at this one, it is at the 5th row, it is at the 4th row, okay, 4th row, and the third column, in which in the same way you go to the 4th row, 3rd column, yes, it is available, you retain that value. Similarly, you go for the next pixel, it is at 6th row, that is at 5th row, from the right, that is the 3rd column, you just check it here, is it a 1 here? If so, then you maintain, okay, it is a 5th row, 1, 2, 3, 4, 5, 5th row, from this one, no, it is not there, you just make it with a 0, there is a 0 will be come out from this one. Similarly, you just observe this second image, when the A complementary image, if there are any common elements will be available, you maintain that, or else you remove it. And after performing, okay, after the operations, you will end up with the image that will be fine thinning operations on a image, so that you will end up with a boundary of an image. Okay, it is just a simple operations what we have performed here. Okay, now look at this one with respect to the block. Okay, how we will perform. There are like 3 components are given here. Same equation will be given. 3 components C, D and E. Okay, now A will be considered as apart from this one, whatever we have available. Okay, that is, this will be the space which is available, it is considered as A, and the C is a component, D and E component, intersection. Now W is a structuring element. Now W minus D is nothing but this D, you keep it here, that is W minus D. Okay, now whichever the portion, okay, W minus D, okay, the other portion will be W minus D, you will end up with the values. Similarly, okay, A complementary, okay, complementary in the sense whatever the white space is there, that will be converted into black, and the black of this boxes A, B, C, D, A, B, C, all C, D, E, all turn to white. When you slide this W on an image, you will end up in the image like this. This is the image. You will end up with the image here, because all the way W will be getting slided here. Okay, wherever the common space is there, okay, that will be retained. That is what the common. The other portion will be get erased from the space. Similarly, when you're performing, the W will be getting slided because I'm performing the erosion operation. When you're sliding on this one, it will be getting erased. You will end up with only this is a portion. Okay. Now, what are the next portion? Next operations it will be involved here. Okay, that is complement. That is a intersection. Intersection of what? The first image. Okay, how you obtain, and the final image. Okay, that is a complementary erosion of B2. Then you will end up with a final result here. This is what the answer. Okay, like look at this one. Okay, because they're like which are the common portions, which are the commas. This is what the common portions which is available. Okay, now you will end up with a boundaries. Okay, anyway, okay, I'll just give it with a better example for you. Okay, now I hope you can see the square boxes. This is your A and the structural element B. You go on match on each pixel by pixel. You first keep this one, keep this pixel on here. Okay, now when you keep it here, okay, you consider that these boundaries are 0, zeros. All boundaries will be 0. Is it exactly matching here? No, you make it 0. So I made it 0. Similarly, okay, now you drag this structuring element here. Okay, now in the boundary this is a 0, this is 0. Is it exactly matching? No, you erase it here. Similarly, you keep it at this position. Is it exactly matching? No, you erase this. 3 pixels got erased. These erased here. Okay, same way you just drag it in this fashion. All the line will be get erased. Okay, very interestingly, I'll come to this point. Okay, I'll come to this point. Okay, now is it matching? The boundaries will be 0, zeros. Is it matching? No, you erase this. Okay, now when you keep it at this point, okay, very interestingly, all the corresponding pixel of this values are getting matched with the B1. You retain this. Okay, same way this will be get erased. Okay, now this will be erased. Okay, and this will be retained. This will be retained. This will be retained. Okay, so only the portion will be got erased. Okay, now after the erase you will get here this one. Okay, this pixel will be retained, this will be retained, this will be retained, and this center pixel will be retained. Okay, same way when you drag it on, this will be retained, this will be got erased. Okay, now this is erased, this will be erased, this will be retained. Okay, this will be retained, and all other will be erased. Okay, same way when you keep it here, anyway. Okay, because the 3 will be matching, the 4th is not matching, it will be erased. That means all full line will be get erased. Okay, now this way when you see the output, you will end up here like this. Okay, end up with this one. Okay, there is like, I hope you can see the gray shaded portion and the white shaded portion. You take a complementary of this. When you take a complementary on this one, okay, complementary with respect to the whatever the A first portion, okay, wherever the common portion you retain that. So you will end up here. This will be made it with a white. This portion will be made it white, and this portion will be made it white. This will be made it white. Okay, now here is a white. Okay, you retain this. Okay, this will be white, common point. Okay, you retain this. I hope it will be look like that. Okay, only the interested portion will be highlighted from the image. Okay, highlighted image, that is what the hit and the miss operations. Okay, now this is what the basic application where you can use a hit and miss operation. Okay, to detect the boundary of an image, it will be used most used applications. Okay, now just observing this one. Okay, now this will be like this is the image has been taken by the person. It has got like a boundaries. Okay, of the boundaries, white will be available. I want to retrieve only the boundary of a image. Okay, hope it is clear here. Hope it is given with the boundaries. Okay, the thin boundaries were available. This is what the operations we are performing on a image hit and miss concept. Hope you understood this one. Okay, and I told there is like a built-in functions are available in a MATLAB or Python also. You can perform the hit and miss operations. Okay, thank you.